Hello students, in this video I will discuss the complex analysis chapter. So it is a part of Karnataka University syllabus BSc 6th semester mathematics paper 3. So in which I will discuss in this video examples on Cauchy's integral theorem. As we know that statement of Cauchy's integral theorem or Cauchy fundamental theorem there. If a function f is analytic and continuous at all points within it on a simple closed contour C, then integration of f of z dz over the closed curve C is 0. Or else we can give the statement like this also. Let f be a function which is analytic at all points which is inside and on a simple closed curve C. Then integration of f of z dz over closed contour C, that is 0 there. The logic of when this theorem, Cauchy's integral theorem, can be applicable, only the points which lies inside C. Means what? If you have a given any point and also domain of the circle is given, so the point which comes inside the domain of the circle or closed domain, then this Cauchy's integral theorem can be applicable there. So then we can see that here we need to see the examples of this here, Cauchy's integral theorem. So in the first problem, evaluate integration of 1 over z into z minus 1 over the closed curve C or closed contour C, where C is the circle with mod z equal to 3 there. It means what? See that solution of this problem, it is a contour there, that is the domain there, where the contour C mod z equal to 3, what it represents there, it is the equation of the circle, center at the origin, because it means equation of the circle in this modulus form is z minus z naught equal to r there, equation of the circle. So that means here z minus z naught or z minus a equal to r. So here z naught or a is 0 there. So but radius is 3 units. Now let us define there phi z. That phi z is, that is the 1 over z into z minus 1. And this phi z is not analytic if z into z minus 1 equal to 0 there. Because since if you have this becomes a 0 there, so 1 over 0, this phi z becomes a infinity. Means what? It has a singularity. That's why phi z is not analytic. Suppose if this denominator is 0 there. Now we can equate to 0. We get a points like that is 0, and again z minus 1 is also 1 equal to 0, that is 1. So these we get it, that is 0 and 1 from this denominator by equating to 0 there. Now these 2 points, but domain of the circle is given is 3, because radius of the circle is 3, center is at 0 origin. So definitely it would have this, keep remember here, both points, this 0 and 1 are lies inside the modulus the circle there. This mod z equal to 3 there. Now we need to see here, you can take that expression of this 1 over z into z minus 1. You can split up the terms by a by z plus b by z minus 1. By partial fraction we get it this way, that is a is that 1 minus 1 and b is 1. So then we integrate here. So definitely both are values integrals here. So now we have this function f of z is 1, which is analytic inside or in and on C. Then this integral results we have here by applying that integral formula, but usually this theorem comes in there, but total overall that integral value is 0 there. I need to see that. So by taking a is 1, because why it is a is 1 here. So it is a is 1 in the first integral and a equal to 0 in the second integral, or else in the second integral and first integral. That doesn't matter there. That is f of 1, that is in the first one, and because as we know that is the Cauchy integral formula, integration of f of z over z minus a, it is z minus a, sorry, is z minus a equal to f of a, that is equal to f of a into 2 pi I there. That f of a is this 0 as well as f of 1. This f of 1, since f of z is 1, so definitely it would be again 1 that. So then it is 1 and 1 there. So then 2 pi I into 2 minus 2 pi I, so that it becomes a 0 there. Now we shall move to the next problem. Verify the Cauchy integral theorem for the given function z square, where C is a square which is having a vertices 0, 0, 1, 0, 1, 1 and 0, 1. So see that this is the vertices. Anyway, it is a closed domain because it starts with the origin and move to 1, 0 vertices, and again it's go upward and it reaches to the vertices 1, 1 and again back to this 0, 1 and again back to that is the origin. Definitely it is this domain is a closed domain. So now we can take it f of z, that is z square dz, that z is x plus iy whole square and dz is dx plus I dy, and simplifying making this square there. So product of this again there. That means because since we have a 4, because this line integral we can make use here, this one use then this one and this one there. So that we have a C1 plus C2 and C3 there, all this integral, and whenever you have start with this C1, so it is on the x-axis, so that it is 0 domain of this C, that it is x here 0 to 1 there, so that is a 0 to 1 there. It is a y is 0 here because since it is x-axis. So then we have a, that is a dx and dy is also 0 in the second integral there. So x, that again here it is x is 1 because it is a 1 1 there. So that is a 0 to 1, so that but here x is 1 there because since it moves up to here there. So that's why x is 1 here and dx is also 1. So definitely it would be arrive at that. So that is 1 and it is dx is 0, sorry. It is dx is 0 and this dy is keeping as it is because we are in the y-axis there. So that is 0 to 1 for y limits there. And then you can move on to again, that is from this vertices to this one, so that this line, so it is since again that is the x is 1 and y is x is 1 and y is also 1. So then, but thing is that it is but keep remember here x is, that is starts with 1 and this is again it is the 0 there. So that's why keep remember 1 to 0 we are moving there. So it is 1 and 0 there. So then because we are on the y-axis, so then y is 0 definitely because this is y is 1 but dy is 0 in the third integral there, third one. And then similarly you can have a, that is x is 0 since it is in the y-axis, so that x is 0, dx is also 0, so that ultimately iy whole square only remains. And then ultimately you can simplify this integral so that it, if you got it a 0 results of this one, so that this hence this Cauchy integral theorem is verified. And again also you can verify the Cauchy integral theorem for function is z into e power minus z over the limit unit circle there with the center at origin and radius is unit that. So now we can take the expression for integration of f of z and z replaced by, because since it is the circle there, so you need to take the polar coordinates of the variable z, complex variable z, and definitely it would be arrived like this. So then it would have, that is the re to the power phi theta and e power minus re to the power phi theta, and definitely it is what we have having there. It is the circle C1 just we are mentioning, and since radius is unit because center at origin and radius is unit, that r is 1 and definitely dr is 0 there. But theta is varies from 0 to 2 pi because since it is a circle. So then it would be simplified as substituting r is 1 and dr is also 0, and only we have a d theta and r there. And also you can make use of the substitution method by e power theta replaced by t only, and again you need to translate that everything in terms of t and dt. So then you can make use of the integration by parts, and then over 0 to 2 pi, then it would be arrived at definitely it is 0. So then integration of f of z dz over closed curve, this result is 0. Hence Cauchy integral theorem is also again verified there. And again we can take it, it is also circle, that is unit circle. Then you need to evaluate this integral. But since this contains hyperbolic sine function and exponential function and algebraic function and that terms in the denominator, since the 4 singularities, because if this equated to 0, then definitely it would have been gives, that is the this becomes an infinity, that you call it as singularity. So at which points this becomes a singularity? Only for this equating this here, definitely it would have, that is 2 plus or minus 2 and plus or minus 3i of this integrand, means it this function are exterior. So these points are lies outside or exterior to the disk given it is a unit circle mod z is 1, because since it is plus 2 and 3 there, but domain is 1 there. So that the given function is not analytic on this here, then by Cauchy's integral theorem we have that results definitely integral of integration of f of z over the closed domain, that C, that is 0, provided that points should be, that these points are these singularities lies outside, definitely it would be 0 there. Similarly, we can take it another cos hyperbolic function, but domain of the circle is here given it is the closed curve of the circle, it is mod z is 2 and radius it is 2 and center at origin there. And but thing is that it is in the denominator it is z plus pi and z plus 3. It gives, that is because it has the singularities, these two minus pi and minus 3, and these two are the singularities of this integrand, which are lies inside, which are lies outside the given circle mod z equal to 2, because its domain is only 2 there, but here it is behind, that is minus 3 minus pi there, it is outside that given circle there. So definitely it comes outside, definitely it's, the given function is not analytic on these 2 points. So then by Cauchy's integral theorem, so we have this integral result, again it becomes a 0 over this given circle there. So definitely it is also there. So mod z is 1 here given, circle center at origin and radius 1 there, but 2 it is what there, it is, you get it singularity, it is 2. That singularity is nothing but function is not analytic at that point. So what is the value of that one? So that we know that it is the f of z is z by z minus 2, it is not analytic at this point. So because which gives infinity, it is a singularity. So that's why that. but which lies outside the domain, because since the domain is small z, circle